Hello and welcome to the Westcountry Rivers Trust's Catchment Science Webinar Series. I'm Nick Paling and I'm Head of Evidence and Engagement at Westcountry Rivers Trust, and over the last 10 years I have been heavily involved in many of the Trust's integrated catchment management, collaborative governance and strategic catchment evidence programmes. This is the second webinar in this series of 4 episodes focusing on how we have used a 5-stage proof of concept framework to support the delivery of South West Water's flagship environmental management programme, Upstream Thinking, over its first 10 years. In the first webinar, I gave an overview of our 5-stage approach to using data and evidence to inform the design, delivery and iterative improvement of adaptive catchment management initiatives of this type. In this webinar, the second of the series, I will explain the first 2 stages of our proof of concept process, which focus on problem diagnosis in catchments, justification of investment, pollution source identification, and the methods we use to target our catchment management interventions. During my exploration of these first 2 stages of the process, I will give examples of the various studies we have undertaken and the outputs and case studies we have produced over the years. Perhaps most importantly, the presentation will include all of the links you need if you would like to find out more information about any of this work. So let's get started. Starting off with diagnosis of the problem and scheme justification. So back in 2010, South West Water commissioned Westcountry Rivers Trust to undertake 17 drinking water protected area catchment investigations, and the aim was to support the development of the Upstream Thinking planning process that was undertaken in the periodic review 2014. As you can see, the catchments were distributed widely across the southwest, and each catchment investigation, which was a comprehensive review of all the data and evidence, many of which included monitoring, mapping and modelling work. All 17 reports are available for anyone to look at, and there's a huge amount of information where we tracked water pollution challenges from the water treatment works all the way back up to their sources in catchments. And indeed, this work then led on subsequently to us delivering water quality risk assessments in internationally designated river catchments for natural England across the whole of England. And the YouTube link here is actually a video that we made about those water quality risk assessments. There's about 20 of those that we undertook subsequently. So it's a very good starting point, and the main remit of the study was to develop a really clear understanding of the need and the potential of catchment management to deliver demonstrable water quality improvements in catchments such that the drinking water treatment process was more robust and indeed potentially had the potential to save South West Water money in the drinking water supply chain and treatment process. So for more information, if you're interested in these projects, then have a look at the PRO9 catchment investigation reports. So just as a quick excerpt from those studies, one of the key ones was the CROWNHILL Water Treatment Works study, catchment investigation. CROWNHILL Water Treatment Works is still the water treatment works that supplies drinking water to Plymouth in the Tamar catchment. And it was through the investigation process that we really started to gain an insight into the way that water quality challenges impacted on South West Water's business, particularly on the drinking water side. And we learnt through this evidence review that reduced provision of water supply in certain areas of the drinking water catchment, increased pollution load in those raw waters, those 2 factors combined to create risk for South West Water and indeed increased costs for South West Water in the drinking water treatment process. And so you can have a look at that in more detail in the CROWNHILL investigation report. But just as an example of that, what we learnt was that as this chart shows, when South West Water changed their raw water source in response to water resources management issues or water quality issues, then you can see, as you can see here in the summer when they switched to the river sources in the Tamar, you can see a significant increase in the cost of treatment and provision of drinking water. So this gave us the very first early insight into the kinds of challenges that South West Water were facing as a result of water quality challenge coming from drinking water catchments. And we went on to do a lot more work on this over the following 8 years. And I'll give some more information about some of that work later in this webinar and also in a subsequent presentation. So there's a key thing that we learned, that was increased treatment cost is the result of increased pumping costs, but also increased purification costs. So every time South West Water have to take action or change their behaviour in response to raw water challenge, then there is a cost implication and a risk implication for them. So the next stage in the process for proof of concept is that we use data and evidence to find sources of pollution in catchments. We started to gain insight into how water quality challenges affect South West Water's business. The challenge then for us was to work out where are those problems coming from in the catchment, and then try and design catchment management interventions that mitigate those problems. And we use modelling as our first stage in this process, built on a very simple conceptual model of source, pathway and receptor. And so we have used modelling and data and evidence to undertake a robust environmental risk assessment, with this key thing that we need to characterise the pressures in the system and determine where those pressures are coming from in order to fix them. And so we came up with this conceptual idea that we are looking for areas with the greatest opportunity for improvement through catchment management, and these are identified as being the areas where the most risky land management practices or behaviour is undertaken in the most inherently risky parts of the landscape. And so we came up with a fairly simple risk assessment technique that allowed us to try and identify where inherently risky practices were combined with inherently risky characteristics in the landscape. And from there we were able to undertake, in this case for the Tamar catchment, water quality risk assessment mapping to identify where we thought pollution was most likely to be coming from, and then indeed we used monitoring to verify that this was a good indication of where we should target our catchment management interventions to get the greatest potential reduction in pollution loads. So if you're interested in that, then you can look at the Ecosystem Services catchment evidence reviews that we've undertaken for certainly all the catchments in Devon and in certain areas of Cornwall and other parts of the country as well. There's around just over 30 catchment evidence reviews that we've undertaken, and here's an example of some of the outputs in the Ecosystem Service evidence reviews that we developed between 2011 and 2014, showing some of the maps that allow us to identify where these high priority multifunctional ecosystem service providing areas are in a catchment landscape, so that we can really target in our catchment management plans to try and get the greatest outcome in terms of enhancing ecosystem service production and therefore in terms of water quality particularly and flow, achieve the greatest outcomes in the environment and in the drinking water supply chain. So another type of model that we've used extensively are what's called source apportionment models, and these maps are from a study that South West Water commissioned us to do using a variety of different source apportionment models, in this case for nutrients, nutrient pollution, and using the standard psychic phosphorus mapping, risk mapping model, but also looking at other source apportionment models, the export coefficient model plus, and the source apportionment GIS, which is a water industry source apportionment model, and you can see the different data sets and evidence layers that feed through into that. And if you're interested in this work, then you should have a look at the South West Water Tamar nutrient source apportionment modelling report from which they came, and that report is available for people to have a look at. Another risk modelling tool that we use for targeting catchment management interventions is SCIMAP, which is a sediment erosion risk mapping framework. It's a powerful visualisation and engagement tool that can be applied at a variety of spatial scales to target pollution risk areas. And in the main map here, you can see this being applied at a sub-catchment scale with very fine resolution digital terrain data. And it's a very powerful tool and very accurate tool for targeting erosion risk areas. But also we've used now a drone to collect incredibly high resolution terrain data at the farm, yard and even plot scale, as shown in this example here. And our report on drone surveys of farms to do hydrological runoff modelling is going to be the content of a separate presentation webinar. So keep an eye out for that. And that allows us to actually track the movement of water through farm infrastructure at the finest resolution possible, in this case 5 centimetre topographic data. So it's a very powerful tool for identifying where water is moving and what might be done to target interventions to disconnect those pollution pathways if they exist. So in addition to that, during Upstream Thinking 2, we have also been working to develop a pesticide simulator, which is a model with many modules in it, which allows us to try and identify areas of risk and times of risk of when particularly acid herbicides are likely to be moving through our river systems. And just a very quick summary of this, because then again this is the subject of another presentation in this webinar series. But the simulator has hydrological components, modules, looking for some of these risk factors in terms of where pesticide mobilisation is most likely to happen. It also has quite a sophisticated soil hydrology model in it, which allows us to look at the way that water is running off or moving through different soils in a catchment. And that comes together to allow us to simulate the loss of pesticides, in this case over a year. And you can see that as the rainfall and flow response, shown in blue, responds to in the river, you can see a corresponding spikes of pesticides, in this case MCPA, also coming through in flushes in the system. And we've tried to validate the simulator with South West Water's pesticide detections data, and it's pretty good representation of the kinds of dynamics and the timings of when pesticides are likely to have been found in some of our drinking water catchments. And again, this is the subject of a subsequent webinar in the series as well, so keep an eye out for that. And the other way that we search for sources of pollution in catchments, as opposed to modelling, is to use a variety of monitoring techniques, so survey and sampling for pollution source apportionment. We undertake quite an extensive programme of water quality spot sampling, and we combine that with the use of in situ water quality monitoring kit, and we have now developed a water quality monitoring toolkit which we can apply at a variety of spatial scales and temporal scales to characterise problems in catchments, track pollution sources, and also with an aim to detecting change in the water environment as a result of our catchment management interventions being delivered. Using our water quality spot sampling data collection, we've then developed this technique of a report card for a catchment, which allows us to try and identify where in catchments, large, medium and small, we think that certain pollutants are occurring at very high concentrations on a regular basis, or indeed where there's significant load. And these report cards have been very useful both as an engagement technique for getting people interested in water quality, but also for targeting our farm advisors and catchment management delivery teams as well. So all of the water quality monitoring work has been written up as a series of case studies, and these are all available if you're interested in looking at some of these report cards and the outputs from our water quality monitoring programme. We've also pioneered with South West Water the use of passive sampling for pesticides, particularly acid herbicides and metaldehyde, using chem catchers to look for to do pesticide load apportionment in catchments. The example given here is some data collected on the River Tamar from different tributaries showing different pollutants coming through in different concentrations. There is a film that we've made that you can have a look at, and also all of the ChemCatcher passive sampling data has been again turned into some report cards which you can have a look at. They look like this, and this is a way that we found that's quite useful to show where different pesticides are occurring in different locations within a catchment, again with the sole purpose really of helping us to target our advice and farmer engagement in relation to pesticide pollution and mitigating its effects. So the final thing in terms of monitoring, and obviously possibly the finest spatial scale, but obviously one of the most effective ways of doing it, is actually to have boots on the ground, farm advisors and monitoring team out in the landscape, assessing the health of the landscape, assessing the health of the natural capital features such as soils particularly, and we have delivered a whole programme of wet weather walkover surveys, farm surveys, soil condition assessments, mainly led by the farm advisors but also supported by the monitoring team, and this really is the best way of finding pollution sources at the finest possible scale. And if you're interested in this work, then all of our farm case studies and surveys are also written up and are available. And as someone from DEFRA recently said to me, it's at the farm scale, at the absolute finest spatial scale, where truly integrated, tailored and targeted interventions are designed and delivered. And this is upstream thinking really in action. It's working with the farming community, with rural industries to understand the health of the farmed environment and to target interventions into the right place. Okay, so finally, more recently, towards the end of Upstream Thinking 2, Westcountry Rivers Trust, along with South West Water, have become involved in an Interreg 2Cs funded project called Pro Water, and this is very much focusing on a whole system integrated assessment of water resources management at a landscape scale. And we've been developing a case study looking at a whole system approach to understanding water resources, of which catchment management could play a critical role. And to that effect, we have developed a conceptual model of how water resources are managed and moved around and used in a whole system water supply area. And we are now building a model which allows us to assess the effects of catchment resilience, catchment management, ecosystem restoration on this system, and the way that costs are incurred and the way that impacts cascade through the system, and indeed how benefits from catchment management and ecosystem restoration also accumulate and move through the system of this nature. So this is very much a work in progress, but the model does exist, and if you're interested in that, this will also be the subject of another webinar, and also there is a report on the cost savings study that we've undertaken for South West Water for the periodic review 2019. And the simulator has actually been turned into an interactive dashboard that allows us to look at different scenarios, situations such as pollution, drought, in that whole system, and you can then see how costs or savings accumulate and flow through the system as a result of those different impacts arising at certain times during the year, for example. So that's the end of the second webinar in the series, which focused on problem diagnosis in catchments, justification of investment, pollution source identification, and the methods we use to target our catchment management interventions. I hope you found it interesting, and please note that all of the outputs set out in this webinar can be found via links in the supporting information provided alongside the video. So thanks for watching this Catchment Science webinar. Please do join me again for the next presentation in the series, which will be episode 3, in which I'll be examining the third stage in the process in much more detail. So here's a reminder, the next webinar in this Catchment Science mini-series will focus on the proof of concept work we've done on the delivery of catchment management intervention actions, including in relation to scheme governance, investment mechanisms, and developing our integrated catchment management interventions toolbox.